This is Mario with MIA Microflight, and this is my Core XY Ultralight 3D printer. The machine architecture is built from 13mm square tubing, aluminum extrusions, PLA 3D printed parts, and carbon rod linear rails on PLA bushings on all three axes. X, Y, and Z are running on those carbon rods that you see there. Those are 4mm carbon rods, and it's all belt driven on all three axes. Both the hot end and the feeder, or some people call it the extruder, which is not really an extruder, it's a feeder. It's a filament feeder. They are both from a Turnigy Fabricator Mini 2, a second one that I took apart in order to redo that machine, but I ended up building this instead with those two parts. The rest of the servos, I had to buy those separately for all 4 points here: the X, the Y, and 2 Z motors that operate the Z axis. The control system here is a basic ramps 1.4. This is a clone Mega 2560. It's sitting underneath the drivers there, the driver board. I had some issues with this initially uploading firmware to it. After spending close to a week, I finally got it working. And it's these boards are very, very tricky to upload to, because you have to not only download the drivers that work with these Chinese clones, but you also have to constantly be trying to hit the right timing so that the firmware uploads to the boards just right. I ended up doing the holding the reset button until it was ready to upload firmware and letting it go. That's how I got this board to run. Otherwise it would not run straight as it should. I mean, it's kind of crazy that you have to hold the button, the reset button, until it loads, and then wait for that proper timing. So quite a bit of time lost in doing that. But what I like about these boards is that they are modular, and you can, if something goes wrong with, say, the driver, you can just pop that circuit out and just replace it, which I eventually did, because the top portion of this board, when I first got it, also was bridged on 2 of the pins and shorted my driver here on the X-axis. So I fixed that. I also blew the 5-volt regulator on the main board. I replaced that, and I ended up soldering 2 leads from one of the ground copper lines underneath the 2560 that actually opened up. I was so thin that it opened up, so I ended up going figuring on those 2 points that it went to, and I ended up wiring 2 little wires directly to the ground. It came from the ground side on the connector of the USB case. So that got fixed. I finally got this running. This is running a configuration from an Ender 3, of course modified, to run on this machine. With this is set up for 180 millimeters, both on the X, Y, and Z. The dimensions of this machine, these are tubes that I had from I bought these tubes from Hobby King a while back, many years ago, when they were selling these to make quadcopters. The very early quadcopters that people were making were done with aluminum extrusions, and so Hobby King was selling these extrusions, and I ended up buying a bunch of them just for general projects. And so this extrusion is not your typical 2020, so it's very lightweight extrusions. They are 13mm square tubing by 1mm in thickness. So it's a very lightweight machine, but once you start designing a machine in a cube form, especially with this type of bracing that braces all on all 3 sides, you end up with a pretty sturdy structure. And so that's pretty structured. It's lightweight, but it's very structured, very well rigid, in other words. The gantry here is on the X-axis, is run on 4mm carbon rods. You see there's 2 on top and there's 2 on the bottom where this unit rides on. I redesigned this part right here to use also these bushings, these PLA bushings, which work great, by the way, with carbon rods. Very, very fluid, and very inexpensive and very quick. And so I redesigned this part to use 2 additional ones at the top, but I held back on printing that part because I figured, if I just do a part like this, with just a track, I can just slip it under the original one and run it that way. So this machine has been running that way, and it's been working very, very nicely. I did have some issues with the sensors here that I was printing just fine a night ago, and then in the morning I tried to print again, and that my temperature sensor was not reading correctly, so I had to fiddle with that. But I also had to fiddle with the hot end here, because the hot end, as it comes from the Fabricator Mini 2, which this is from, it has a very funky setup in the connection of the Bowden tube to the existing to the part where to the heat break, which is inside this aluminum heat sink. And so they use another coupler on top of that heat break, and then you put the Bowden tube, so it introduces a lot of areas where the filament can get stuck, and so you have jams. So what I did was I took the heat break and I drilled a 4mm hole right through that heat break, and I ran a Bowden tube, a section of a Bowden tube all the way down to the very bottom, so it's flush with the nozzle. So when when the heat break meets the nozzle, it's very flush. So there's no way that the filament is going to creep up on the sides or create some kind of a bulge, where it's very difficult to remove the filament in case it gets stuck there. So now it's printing beautifully. I did the same thing to my Turnigy, my first Turnigy fabricator, which I still use to make small wheels. Basically the same wheel that I'm printing here. And so that's working very nicely. And so that's the reason why I use the second one here too, and I made the same improvements, modifications to the head. So now it's running great. This was originally underneath here, and my idea was to run this in line with the center of this carriage here, but it just wasn't working out right, and I had issues with the heating. It was overheating the plastic, the PLA. And I think it's because I didn't have the fan turning on at the proper time, so this was getting a little bit warm, and it was softening the bracket that I had holding this whole assembly. Now I have an aluminum bracket, but it's spaced out with a fiberglass sheet here. So as a heat break between the heat sink and this aluminum part that's underneath this tray here. This tray just slips right there and slides right in there, so it's easier to take out in service. I was going to do it with magnets, but this worked really well, and so I decided to leave it like that. So it's a nice little tray there, and it's working beautifully. What else? I need to clean up these connectors here, so I ordered some connectors so that I can match the existing ones that were part of this cable system here. And the reason why I don't want to break this and put my own connectors there is because in case I want to reuse this on the second fabricator that's in pieces right now, I can just pull these cables out and still reuse it the same way as the original one. So there's no need for modifying that section there. The belts are simply attached to these blocks just by a loop around a bolt that sits in the middle here, and that provides enough tension there to clip the belt on itself, teeth over teeth, and so it's not going anywhere. So that's very very clean and very effective. The cables underneath, I do need to clean that up, but I started making these clips here for the side cables. You can see those clips there. And that is that cleaned up this area right here. And I also need to route this cable on the side here so it's out of the way. And I have to move my control board back. I think I'm going to put it at the back here because the connectors to the LCD display are long enough that I can move that back. Remember, this is a 300 by 300 footprint machine by 300. All these tools came as 300 millimeter in length, and so that's what I use. I didn't modify that or cut. This table right here is just a piece of masonite. I had a bunch of these little squares from a previous project, and so I decided just to rubber band this, rubber band it in place here over this frame here. The frame underneath is also carbon rod, and it's clamped on the carriages for the Z-axis. There's one there. There's another one there in mirror image. There's also 4mm carbon rods with these brackets here. To give me a frame that I can work on, work from. These are perforated at the corners here so that I can put springs here and do my regular table with adjustable knobs here for height adjustment. So it's been working very nicely over this painter's tape. It's over this masonite piece of wood here or board. But eventually this will be a hot end bed. In the future, in the near future. I just wanted to run some parts here and see how they were coming out. So this part I just recently printed, and the bottom is not that pretty, but it is making consistent parts. I ran this last one at 500%, which is it took about 10 minutes and 15 seconds at 500%. To make this part, and the part is coming out with consistency in layer height and layer thickness. It's a very nice little part here. It's got a couple little things here and there, but it's very minor, and I think that's due to the rods. These rods are not precision rods, being that they are carbon rods, but they are 4mm as close as possible to that dimension throughout the rod, and I made sure that I went over them with a very fine grit sandpaper to remove any imperfections here, so that they would ride smooth inside these PLA bushings or bearings. These PLA bushings are they have a 3-point contact. They're designed in delta. If you look at really close at that. That one right there, you can see how it's got these openings on the 3 points there, but it also has 3 points of contact, very small points of contact throughout the height of the bushing, so it's able to ride on these rods very smoothly. It's working very nicely. I was going to use metal linear rails, but they were a little too heavy, and I thought, if I wanted to speed this and have the acceleration and stop times that I was looking for, I would have to minimize as much weight as possible on the head, on this whole assembly that travels X and Y. The Z, it doesn't really matter because it's just it's step by step. But this is the one that's doing most of the work, layering the filament. What else can I say about this machine? The pulleys. These were pulleys that I had from a previous job as well. These are 3mm in height, and so I had to double them up here with these PLA inserts to create the flange. These flange they look like washers, but they're actually 2 flange pieces with a stem inside to support the ball bearings. So there's 2 of them per belt, because each one of these belts is 6mm in height. So 2 times 3 is 6mm, so that gives me the width to run these belts through them without any binding. These are bolts that go right through the 3mm thickness of this PLA part, and also through the top and bottom of this aluminum extrusion, and it's all at the bottom. So this is very rigid. This right here I had to double up on the at the top and the bottom. You can see the very similar blocks here with the carbon rods inserted in them, and so this was to create a little more rigidity on the X gantry, the treble of this block right here. So that resolved some earlier problems that I had. Not really problems, but it was flexing a little bit, and I don't want to have any flex whatsoever on the X axis. And so by introducing this top block on both sides here with 2 additional rods, and sort of retaining it here through this bearing channel slider, it resolved that issue here, and it's printing with precision. This right here used to be a or is a cable holder when I had this directly underneath this block. So all these cables came on the side here, and it clamped right here. But since I moved this to the front, I need to make provisions for another clip here, so that this is more vertically and more a little more clean. Otherwise, it's running very nicely. So this is my very lightweight, very lightweight machine, and I'm just a believer of non-brute power. I design ultralights, I design microlights, I design very tiny little helicopters that are super lightweight, and I just don't like using brute power to power things. I see people building planks, you know, with heavy with heavy materials, and they end up using, you know, also brute power. You know, to the only way you can get those things to fly is by brute power, and I'm not a believer of brute power, and I'm more of an efficiency nut, and so that's why I did this machine the way you see it here, and using these components that I mentioned I had laying around, because they just lend themselves to a very rigid structure, but also lightweight and efficient. Efficiency is key in a lot of these things. You don't want to be running things. This runs at 12 volts just fine, and so I didn't, like I said, I didn't want to introduce too much excessive power and heavy components. You know, the architecture of this machine is very similar to a lot of the Core XY machines that are out there, but if you look at the details that I mentioned here and how it's built and what I'm using for linear guides, I think this is the first machine out there to be done this way, you know, with these 4mm carbon rods on PLA bushings. There's a lot of machines that are out there, you know, they're using linear rails, really heavy extrusions, and on top of that they put, you know, these metal rails, solid metal rails. On top of that you have the ball bearing trucks or carriages. You know, you end up with a lot of weight. In my view, it's unnecessary unless you're, you know, building a metal parts or something like that. But, you know, for PLA parts, you know, you really don't need that level of complexity and that level of math in the machine. I mean, look at these parts that are coming out. They're very nice little parts, very consistent. I'm in awe of the quality of the layering that's happening here. I didn't think I was going to be able to get better layering and better finish on the surface of these parts with this first prototype. But, you know, I think that's the beauty of the Core XY system, is because you know, this particular mechanism, you know, that uses the X and Y on the same plane, it really produces some very nice parts, and you don't have to you don't have to spend too much time thinking about that, because the software is already designed to do that. All you do is hit the make this a Core XY machine and firmware, and provided you have set up the other things correctly, everything just runs nice and neat. There's a lot more to that. I mean, I'm making this very simplistic because designing a 3D printer from scratch, there's a lot of areas that you need to be proficient in. You know, not only designing parts from scratch is an art in itself, and how to manipulate the CAD, how to save that, how to slice the file, how to set that up so that you get good prints. That's an art in itself. But a mechanically complex machine such as 3D printers are, that takes a certain level of mentality and persistence, and it's not for everybody. Otherwise, everybody would be building machines and not buying any of the commercial ones that are out there. But I do have some commercial ones that I use, and this is kind of my fun project that I decided to do because I have a little time these years, and so I decided to put this together and just take my time. I mean, there have been hours that I have been cursing some of these things that they don't work as I wanted them to work, but I finally resolved them. If you're persistent and your mind is set on getting something done, you're going to do it. That's just the nature of how things are. If you really, you know, when I aim at a target, I aim to hit it. I don't deviate. You know, I look at that target and I say, I got to hit that center, and I'm going to hit it. And so that's how these things are. You know, when you set your mind to doing that. So you're seeing this little machine. It needs a little more cleaning, but I should be doing that in the future, and we'll be running this a lot more. Stay tuned for more.